Look around you. We are surrounded by structures, buildings reach for the sky, bridges span vast rivers. Even a simple chair is a structure designed to support your weight. Have you ever wondered how these structures stay upright and stable? The answer lies in understanding fundamental engineering concepts like trusses, centroids, and centers of gravity. These concepts might sound intimidating, but they are actually quite fascinating. They are the building blocks of structural analysis, a field that allows engineers to design safe and efficient structures. In this essay, we will embark on a journey to unravel the mysteries behind these concepts. We'll learn how they are used to analyze and design the structures we rely on every day. Let's start with trusses. Trusses are everywhere. Look at a bridge or the roof of a building. You'll likely see a network of triangles. These triangles are the hallmark of a truss. A truss is a structure composed of slender members connected at their ends by joints. The beauty of a truss lies in its efficiency. By using triangles, trusses distribute loads effectively, making them strong and lightweight. This is why they are used extensively in bridges, roofs, and other structures where long spans are required. Trusses come in various shapes and sizes, each tailored to specific applications. Simple trusses, as their name suggests, are the most basic type, formed by connecting three members to form a triangle. Compound trusses are created by combining multiple simple trusses, while space trusses extend into three dimensions, like a geodesic dome. Understanding the different types of trusses is essential for engineers to select the most suitable design for a particular structure. Now that we know what trusses are, let's explore how engineers analyze them to ensure their stability. One common method is the method of joints. This method involves analyzing the forces acting at each joint of the truss. By applying the principles of equilibrium, engineers can determine the internal forces in each member of the truss. This analysis ensures that the truss can withstand the applied loads without buckling or collapsing. Section 5. Analyzing trusses, method of sections. Another powerful tool in a structural engineer's arsenal is the method of sections. This method is particularly useful for analyzing larger and more complex trusses. Instead of analyzing individual joints, the method of sections involves cutting through the truss and analyzing the forces acting on the resulting free body. By applying equilibrium equations to the free body, engineers can determine the internal forces in specific members of the truss. Section 6. Centroids. Finding the balancing point. Now let's shift our focus to centroids. Imagine balancing a ruler on your finger. The point where the ruler balances perfectly is its centroid. In essence, the centroid is the geometric center of an object. For simple shapes like rectangles and circles, finding the centroid is relatively straightforward. But what about more complex shapes? Section 7. Centers of gravity. Where weight acts. Closely related to the concept of the centroid is the center of gravity. While the centroid is a purely geometric concept, the center of gravity takes into account the distribution of weight within an object. It is the point where the entire weight of an object can be considered to act. For objects with uniform density, the centroid and the center of gravity coincide. However, for objects with varying density, these points can be different. Section 8. Calculating centroids and centers of gravity. Calculating centroids and centers of gravity is crucial in structural analysis. For simple shapes, formulas and tables are readily available. However, for more complex shapes, engineers may employ numerical methods or graphical techniques to determine these points. Understanding how to determine centroids and centers of gravity allows engineers to analyze the stability of structures and ensure they won't tip over. Section 9. Mastering structural analysis. Congratulations! We've journeyed through the fascinating world of trusses, centroids, and centers of gravity. We've explored how these concepts are essential for understanding the stability and strength of structures. Remember, the key to mastering these concepts is practice. By working through examples and solving problems, you'll develop a deeper understanding of these fundamental principles and be well on your way to becoming a structural analysis guru.